Hey, g'day, it's Prezzo here. Welcome back. This is episode 4 of Metal Finishing with Mark. And the title of today's video is Metal Engraving 101. Now, during this video, I'll use the terms etching and engraving interchangeably. But essentially, what we're going to do is learn how to mark either text or images on the surface of a piece of prepared metal. Now, these two discs here are made of aluminium, and I demonstrated in my last video, Anodizing 101, how to anodize these in the home shop. This one here is stainless steel, and we're going to demonstrate a technique for not really etching, not really engraving, but essentially changing the color of the surface of that stainless steel. Now this one here we're going to do in a 50 watt CO2 laser, sort of a home shop type laser. And this one here we're going to do on the CNC milling machine using a process called diamond drag engraving. But this is the one that's got me really excited. I learned how to do this some time ago. What we can do is prepare the surface of this stainless steel and then change its color. Now it's not really engraving and it's not really etching, but the result looks like this. So this is a little disc of stainless steel also, and that's my ugly face that you can see there. And that coating that's on there is very durable. It's pretty hard to get it off. And it's not a layer of paint, it's not a layer of anything really. What we've done is we've alloyed the surface of the stainless steel with zinc. And you get this beautiful contrast. It's like a dark charcoal grey against the polished stainless steel background. So we'll do that one later, but let's get busy with this one first. We're going to laser engrave this and create that image on that piece of anodized aluminium. Okay, this is my 50 watt laser. This is a CO2 glass tube laser. You can buy these on eBay now. They're not terribly expensive. I got this one second hand and it was in a pretty poor state when I got it. It took a lot of work to get it where it is now. But in terms of a workshop tool, I find it excellent for doing things like prototyping, for decorating parts, if you want to do making up your own nameplates for machinery or tool racks. You've just got to think about it as a tool and then use it accordingly. The one thing about having it here in the wood shop is that we've got to be careful with dust. It's an optical instrument, it has mirrors and lenses, so you do need to be careful and protect it from that sort of environment. So I've got a big barbecue cover I put over this when I'm not using it. Seems to protect it quite well. And what we're going to do today is we're going to engrave a circular pocket in a piece of MDF, and this is going to be used to register our part. So we're going to put our aluminium disc into that engraved pocket, and then we can be sure that we've got this registered accurately when we go to do the engraving on the metal. Now if you think about it, there's nothing worse than investing a lot of time in anodizing this part and then putting it in the machine and sort of guessing where it has to go. And then you find out that once you started engraving it, that it's not centered or it goes off the edge or something horrible like that. So you've got to think around how do we ensure that we're going to get our engraving exactly where we want it. And that's by getting this little pocket already prepared. So let's have a look at that. This is where I do all my 2D design work before I go to the laser engraving software. This is CorelDRAW. If you don't want to pay for it, CorelDRAW, you can use Inkscape, which is a vector drawing program. It does essentially the same thing. So I've drawn everything you can see there accurately to size. The orange circle represents the size of the aluminium disc, and the blue shape over the top of that is what we're actually going to engrave on the anodized surface. So let's have a look at our laser engraving software. So this is it here. This is called LaserCAD. It came with the digital signal processor I use on my laser. Now some cheap Chinese lasers that you buy will have their own proprietary software, which is usually pirated, and as such it's sort of very user unfriendly. A lot of the time it will have really bad translations on all the buttons and the text and the menus and so on, and you're basically locked into it. There's nothing else you can do apart from using that one particular software. And that's because they encrypt the signal between your laptop and the digital signal processor. They'll make you use a dongle, which will unlock the digital signal processor and allow it to accept the data from your laptop. So if you're thinking about buying a laser, steer clear of any of them that require a dongle. you're better off to buy one that sort of uses more open source software, and then you've got the opportunity to upgrade at a later stage. In any case, what I've done here is I've got two layers. The blue layer we're going to engrave, and the orange layer will also engrave. The thing is, you can tick or untick a layer, and that way you can separate out how you're going to engrave. So in my case, I'm going to first of all engrave that orange circle as a full depth pocket. When that's done, I'll untick the orange layer and I'll tick the blue layer, and that will allow me to engrave the symbol on top of the circular disc. Got to be careful, be absolutely sure you know what the laser is going to do before you get there. The thing about this is it has a preview. So if I tick simulate, you can see it is actually going to engrave the full circle and nothing else. If I untick the blue layer and I tick the orange layer, let's try that again, and now you can see it's going to do the engraving of the symbol itself. So do check that simulation before you go into your machine, because it might do something unexpected. So what we'll do now is we'll switch the laser on, and we're going to send that data to the laser. The laser has its own memory, and the jobs are actually stored in the machine itself. So even if you're switch your laptop off, you can still access those jobs and run them on the machine. I've got a lockout switch on the lid of my machine, which makes the machine safe, so you're going to have the lid down before it'll run. I've disabled that just so the camera can see what we're doing here. As long as you know your way around the machine, it's sort of safe, but you absolutely should never place your hand anywhere inside the machine while the laser is activated. Ask me how I know that. Yes, the thing about these CO2 lasers too is if they burn your skin, the beam is unfocused usually. You've got to be able to get your finger underneath the lens here, to actually have a focused beam on your skin, but it's still going to burn a hole about, I don't know, like a quarter of an inch in diameter, and for some reason the wavelength of light that CO2 lasers use burns below the surface of the skin. It's quite a nasty burn. Okay, let's run this pocket now, and then as long as we don't touch this piece of material, we can drop our little disc in there and know that it's registered properly. Okay, let's cut a pocket about 0.2 millimeters deep. Now you could run a second pass over that if you want to have a deeper registration in the MDF, but all I really want to do is to locate that disc. So we're just going to pop that in there, and you can sort of feel that it's in that depression in the material. And the other thing is that there is an air blower which circulates air through the nozzle of the laser itself, and that could dislodge that lightweight piece of material. So just to be sure, I'm going to put a bit of tape just on the edge there. It's really important you don't move the MDF plate that we've already put in there. If you do that, you've got to start again. So that's just going to ensure that our little disc isn't going to get dislodged when we start the next run. If the tape is over the area that you're going to engrave, doesn't matter, it'll just burn through it. Okay, let's set up the next job. We'll go from there. I'm using a speed of 200 millimeters a second on this run, and we're using power of 75%. On the previous pocket that we cut in the MDF, we were doing it at 300 millimeters a second, same power, 75%. Well, there you go, there it is. That's all finished now. And I think the contrast and the resolution has turned out really well. I did that with a scan gap of 0.15 of a millimeter. You can go down to 0.05, but honestly you don't notice a lot of difference in the quality and the resolution of the finished part. Now the thing is, what we're seeing there now is just the undyed aluminium. I can run my finger over that and you cannot feel any texture at all. So it's not like it's been etched in the normal sense by scraping away the surface of the material. It's not been eroded, it's not been cut into in any way. It's just that we're vaporizing that blue anodizing out of the surface. Now even the exposed areas are basically still anodized, so you're not going to notice a problem with that corroding or oxidizing in any way. I've made these as tags for our cats, and they run around the yard for years and years, and they're still looking good at this point. And you can actually buy these discs on eBay already anodized, and they're sold as tags for cats and dogs and key tags and whatnot. And you could churn these out one after the other. As long as you cut your little pocket there beforehand, you can just drop the parts in and cycle through them one after the other. And yeah, it's simple. So I've made this as a little maker plate for my metal cutting bandsaw, which you might have seen in previous videos. Now really, it's just an adornment. I don't really need it. I made this just to compete with a guy actually on Instagram that I follow, a guy named Steve Smith, and I think I mentioned him before. He has an Instagram account where he showed his bandsaw table, and he had engraved his maker mark in the corner of the table. So this is just a bit of one-upmanship really. So there you go, that's how you engrave or etch anodized aluminium on a 50-watt CO2 laser easily. Okay, for this one, remember this is stainless steel. This is one that I've already cooked up beforehand, and what I'm doing today is I want to make a replica of this little label that goes on the knob. That's from the power feed on the x-axis of my Bridgeport mill. And this is some sort of foil that's probably been screen printed or offset printed in some way, but it just looks a bit shabby and I thought I could do a better job. So I recreated the artwork once again on CorelDRAW, and we're going to use the laser engraving software to generate that image on that piece of stainless steel. Now there is a proprietary product you can buy which you can coat the metal with and then laser engrave over the top of it, and will transfer the design onto the stainless steel. Now the product is called Cermark, C-E-R-M-A-R-K. Now I've never used it, but I understand it works really well. The only problem is that a can of Cermark will set you back between $115 and $140 depending on where you live. And it's essentially just a can of spray paint. You know, for some time I'd been really keen to try this, but I always coughed a bit at the thought of having to pay over $120 for a can of paint. And I'm going to show you a method that you can do easily in the home shop, and it's going to cost you a fraction of that. And this is it. This is what you need to get. Now you can buy this under various different names. It's sometimes called cold galv or zinc galv. This one's made by Dulux. It'll cost you about 12 bucks down at your local hardware store, and it's just a zinc rich paint. Now you can buy this in a can and brush it on, but I find that spraying it on, especially on small parts, works really, really well. And you don't need a lot. It's just like quick coat, let it dry, and then it goes in the laser and we're going to etch straight over the top. Now what happens during this process is that the intense heat from the focused laser beam is going to form an alloy of zinc and stainless steel. And it's basically just staining the metal. So the coating that you end up with is not like a paint. It's like an amalgam of the two metals. It's very, very durable. It gives you good contrast. So you can see that there. You know, good high contrast, and like I say, it's durable enough to be used around the workshop and handling and so on, and you're not likely to scratch it off easily. Now, during this process, while we're actually doing this laser etching or laser engraving, wherever it touches that paint, the metal gets quite hot. And this was the strange thing I noticed. Now, on the back of that, it's got a clear protective film, and you can see the heat has melted through the clear film on the back of that disc there. So there's something going on. I'm not sure what it is, but metal doesn't normally get that hot when you're running the laser over it in the machine. But for whatever reason, it works really well. And yeah, let's demonstrate it. Let's see how it's done. Now I should also mention that the hardest thing about this process is being able to get a smooth, flat disc of metal. So if you try and cut this out with ordinary metal snips or shears, it's going to curl the metal up, and you're not going to see it being dead flat like that. So what I do is I'll cut it way over size, and then I'll trim it back with something like a disc grinder or a finishing belt until I get it roughly circular, but probably about 5 millimeters over size. And then we use a process called pressure turning on the metal lathe. Now if you're just doing a rectangular or like a straight edge plate, it's no problem. Just grind it back on your belt linisher. But if you want it to be truly circular, it needs to be done on the lathe. Now, if you don't know what pressure turning is, check out Joe Piezinski's channel on YouTube. He does an excellent demonstration of pressure turning, and it's simple to do, and you get these beautiful machined edges on your circular disc. So what we're going to do now is give this a coat of that zinc-rich paint. Let it dry, and let's get it in the machine. Now you might want to clean this a bit. It's not really essential. I mean, you don't want to have dust and dirt on it, but really the paint doesn't even need to stick. We're just going to burn through it, and then later on it's going to get wiped off anyway, so don't get too hung up about that being surgically clean. Do shake your can really well. Just spray a bit out too before you actually put it on your material to make sure that you've cleared the tube inside the spray can. Okay, that's about it. So we'll let that dry, and then we're going to do the same thing we did with the anodised disc. We're going to cut a circular pocket to register the size of that disc that we've got, and then we can be sure our engraving is going to go in the right place. Just like we did before, I've registered the position of that disc by cutting a pocket. I actually ran over it twice to make sure it was good and deep. So what we'll do now is change over to the second program, and that will engrave the artwork through the zinc paint and onto the stainless steel. Now the important thing here is you do this slow and hot. So I've got my speed set to 20 millimeters a second, and we've got the power up to 80%. So it's going to seem like it's engraving quite slow, but we need to get the heat to fuse the paint to the stainless steel surface. Okay, now I know that looks awful, but let's get the paint cleaned off and see what it looks like underneath. Oh, there you go. Old dumbass here forgot to turn the camera on while I was cleaning that off, but basically you just use some thinners on a bit of paper towel, wipe off the paint, and that's what you get underneath. Now, I don't know if you can tell, but the surface of that material is no longer flat. So what happens is the intense heat passing through the paint creates localized heating on the surface of the metal, and it just distorts and warps slightly. If I turn that over in the back, you may be able to see that it's also distorted the back. But I reckon the contrast that you get with that is fantastic, and really I couldn't think of another way of duplicating that label. So there's the old one, but I couldn't think of a way of duplicating that label and making it durable enough to stand up to workshop use. Well, there it is. I've given that knob a bit of a clean up, just get rid of all the grime and the paint that was on it. I also just machined the top edge of that was a bit burred over and a bit knocked around. And at the moment that steel plate's just sitting in the recess, so I'll need to glue that in permanently. But I want to put it back on the machine and make sure I get it registered properly with the 0 point at the correct position, because this is secured on with a single grub screw, so I need to be sure I get that right. But there you go, that's That's how you replicate a very durable dial with a legend or with some sort of graphic elements on it and have it last more or less indefinitely. Certainly better than one of those foil stickers that will just peel off when it gets any solvent on it. This should last indefinitely. So there you go, job done. Okay, I need to move along a bit here because this video is getting too long. But what we're going to do today is to drag engrave this anodised aluminium disc in the CNC milling machine. Now this is a drag engraving tool. It was sold to me as a diamond drag engraver, but I got a feeling this is just solid carbide. I've had a really close look at it and I can't see any evidence of a diamond in that tip. Now I bought this on eBay. I think I paid about $90 to $100 for it. Tormac sell a much better one, but it's way more expensive. And I got a feeling this is sort of like a homemade job or part of a limited production run, but the quality is not that brilliant. However, it does work. It came with these two carbide tips. This one here is 120 degrees on the tip, and this one is 90 degrees. Now the 90-degree tip works better in harder materials like steel and stainless steel. This blunter 120-degree tip is better in softer metals like brass, copper and aluminium. I think because it doesn't penetrate so far and it won't raise as much of a burr. Now it's got a spring which is tension up with this socket head grub screw here. However, the thing that increases the depth of cut is just simply setting a higher Z value on your CAM software. So I usually set this to touch the surface of the metal and then to take on a Z depth of -1.5 in aluminium, and that seems to work okay. The spring will allow that point to move up and down inside the body of the tool up to 6 or 7 millimeters. So you've got to experiment, try it out in a bit of scrap first and just see what works. Now what we're going to do is fixture up the disc in this piece of plywood. I'm going to cut a hole with a Forstner bit which is the same diameter as our stock, and that will locate that disc and stop it sliding sideways. Okay, that disc is going to be a fairly tight push fit in that hole there, but even so I'm worried about it sort of rotating, so I'll put some double-sided tape in the bottom of the hole. I pre-drilled a smaller hole in that corner there so that later on when I want to get the disc out I can just poke it through from the back. I got that double-sided tape on there, we'll just pop that in. And of course what I need to do now is zero out my machine so that the X and Y are directly over the top of that already drilled hole, and then we'll set the Z. Okay, so I've set my Z right on the surface of the material. We'll zero our Z there and should be good to go. Alright, so this is what we're engraving today, so it's pretty straightforward, just a bit of text, simple shapes, and what I've done is I've exported that as a DXF file, and then we can open that in the CAM software, which is CamBam. Now CamBam is cheap and cheerful, simple, easy to understand. It was relatively easy for me to learn. I have got Fusion 360 which I'll use occasionally, but for most of what I do this is fine. So in CamBam there's an engraving program which is up here, and it will just simply trace the DXF profile, and all you have to do is set a Z depth and a clearance plane. Now if you're doing rotary engraving then you can also set your feed rate, speeds, and set it up for whatever type of engraving cutter that you're using. But like I say, this is fairly straightforward. Now I've removed the circular outline because we don't want to engrave that, we're just going to do the text. So I've done the NC file, so let's open that in Mach 3 and we'll go from there. Alrighty, so I think we're good to go. This is like a one-shot deal. If you screw it up, there's no going back. Yeah, let's go. I've had a close look at that and I'm not really happy. It's not penetrated very far through the anodized layer, and I think I ran this actually on some plain aluminium just before and it was fine, but I think the anodized coating is tougher and harder and it's just not quite breaking through as much. So I'll run it again. I'm setting the depth at minus 2.5 on this run. Well, that's what it should have been like right from the start. You could see that the carbide point was crunching up that anodized coating and it was coming off like powder. But the other thing that was happening was that that was rotating. There was enough give in the double-sided tape to allow it to move slightly. So let's take it out and have a closer look, but I don't have high hopes. Could have been a fail, Mark. Well, surprisingly, it's better than I thought. I reckon that's okay. Well, there you go. That turned out better than I thought it would, actually. I had a close look at it and I was expecting to see some blurring of the outline as I ran the second pass, but no, it's actually good. And there's very little burr on that. I can't feel any of the burrs that I saw in the first one that I tried on the plain aluminium. So I think that meant changing to the 120 degree point made a big difference. And you could see on the second pass how it was crushing that anodized coating, just turning it to powder. So that one's done, and let's have a look at the other two just to wind up. So there you go, there's the selection. So that's etching or engraving done 3 different ways. And I know you're looking at this and saying, well, I don't have a laser in my workshop, but you know what? You do want one. I know that. So think about that as an accessory for your shop. They are excellent machines and they're very versatile. So I guess the question now is, which one of these two do I put on my bandsaw? Well, as you can see here, I milled a pocket for the little aluminium disc, and it's pretty snug fit. I think if I use that one, I would need to use some sort of adhesive to get that to stick there. It's just below the surface of the table, so it won't get scratched when we run stock over the top there. But you know what? Every time I look at that, I will be reminded that I went prematurely bald. Yeah, that's not going to work. Let's do this one. Now this one is just tight enough that I can probably press that in and it'll stay permanently. So let's do that. There you go. Isn't that pretty? Oh man, is that square? Yeah, it is. It's alright.